Hi all, here's another example of transformations. So we're going to start with a different function. I've named this one y equals g of x. And we're going to apply transformations and see if we can figure out what some graphs of new, slightly different functions look like. Okay, so here's my function that I'm starting with. And the first thing I'm supposed to be sketching is y equals negative g of 2x. Okay, so function g is this one. I would like to apply a negative here to here. The negative outside the function will affect your y values. So it'll flip your y's, which means it's a flip over the x-axis. The 2 is affecting your x's, so it's going to do that whole opposite thing. If I want to keep my y value the same, I actually have to plug in something half as big for x. So this is really horizontal compression. By 1/2. So I'm cutting all of my x values in half in order to keep my y's the same. Okay, so this is going to flip upside down and it's going to be skinnier. It's going to squash towards the y-axis. So I need some room in quadrant 4. Okay, let's see. 1, 2, axes are crooked. 3, 4. I think that'll be enough. 1, 2, 3, 4. Are we doing squunching? That's probably enough too. Okay, so point by point, I have the point 2, 2 looks important. Open circle at 7, 2 looks important. And I think I'll go ahead and just follow these corners to make sure I really get it right. So this is 5, 4, and 3, 4. Okay, so starting at 2, 2, if I'm flipping over the x-axis, it's going to end up down here. And then I'm doing horizontal compression by half. So instead of 2, negative 2, I cut my x in half and it'll be 1, negative 2. So the closed circle ends up at 1, negative 2. 3, 4, when I flip upside down, ends up at 3, negative 4. When I cut my x in half, it ends up at 1.5, negative 4. So 3/2, negative 4. 5, 4, when I flip upside down, ends up at 5, negative 4. And then I cut my x in half, and it ends up at 2.5, negative 4. So 5/2, negative 4. Last one, the open circle was at 7, 2. When I flip, it ends up at 7, negative 2. And then if I cut it in half, it ends up at 3.5, negative 2. It's still an open circle. So negative, oh, not negative, 7/2, negative 2. And again, it should still look like function g. I flipped it upside down, I've scrunched it a little, but it's still going to have the same basic shape, so we should connect the dots with straight line segments. All right, and that's what that one looks like. For b, we have a vertical compression. So this was A. I'm going to do it right next to this one, B. 1/2 g of x plus 3. Okay, so the 1/2, since it's applied to the entire function, that's going to affect y values. So that's a vertical compression by 1/2. And then this is a shift to the left 3. Again, watch the x's. If you want to keep your y the same, you're going to have to plug in something that's 3 smaller than before. So it's actually going to shift to the left. Okay, so again, if I start with this original function and I do vertical compression, it's going to be shorter and closer to the x-axis. And then I shift it to the left, it's going to push over into quadrant 2 just a little bit. Okay, so I'm going to give myself room in quadrants 1 and 2. Okay, so if I start with 0.22, I do a vertical compression by 1/2. It'll move it to 2, 1, and then I shift left 3. Hold on, where was I? 2, 1, 2, 3. It'll end up at -1, 1. So that's the closed circle. The corner starts at 3, 4. If I do vertical compression, it'll be 3, 2. And then if I shift left 1, 2, 3, it ends up at 0, 2. So there's a corner at 0, 2. The other corner, 5, 4, we do vertical compression. It moves to 5, 2. And then we shift left 1, 2, 3. And we have a corner at 2, 2. Last, we have the open circle. It was out at 7, 2. We cut our y in half. It goes to 7, 1. We shift left 1, 2, 3, and the open circle stays an open circle and is at 4, 1. Again, this should still look like G. It's a little shorter. You move to the left a little bit, but it's still that same shape that the original function G was. Okay, one more transformation. Oh, and I should mention it there. Again, to be safe with the order, if you just remember to always shift last, you should be fine. Here, you're not going to get in trouble. You really only get in trouble when you have your shift and your other transformation going in the same direction. So if that was horizontal compression and horizontal shift, I would be worried, or vertical compression and vertical shift, I would be worried. Here, not so much. But rather than memorizing when it's trouble and when it's not, I would say it's easy just to shift last and then plan all of your other thinking around that. Okay, so C. We want to sketch y equals g of -x minus 1. Okay, so again, first thing that jumps out at me is this is referring back to function g, whose graph I have up above. The negative sign attached to the x's is going to flip all of our x's across to the other side, so that's a flip over the y-axis. The -1 is a shift down 1. Again, here this is applying to the entire function, not just the x, so it's going to shift your y values. Subtracting 1 from y does not affect your x, so it does exactly what it says, moves everything down 1. Okay, so let's see. If I flip over the y-axis, I'm going to end up in quadrant 2, and then I shift down 1. I'm still going to be in quadrant 2. So let's give ourselves good room in quadrant 2. 2, 4. Okay, so originally we had 0.22. If I flip over the y-axis, again, save your shifting to last, flip over the y-axis will land me at -22, shift down will land me at -2, 1. That was the closed circle I followed. It's still the closed circle. 0.3, 3, 4, the corner is going to flip across to -3, 4, and then move to the, move down 1 and end up at -3, 3. Okay, 0.54, the other corner, 4, will flip across to -5, 4, and then it will shift down 1 and land at -5, 3. Last key point I'm following is 7, 2. So wherever that sits, somewhere out here. We flip across and it lands at -7, 2. And then we shift down 1. It was the open circle. It's still the open circle. It is now at -7, 1. Again, it maintains the same shape. So between the dots should all be straight line segments. So there is the last sketch transformations. I do have a couple of other parts to this problem. First, part D, we want to add to the graph of G to make a new function that is even. So if I want my function to be even, I didn't leave myself great room here, but this is just a reminder thing. It has to have symmetry across the y-axis. So to g, I would have to add a point -2, 2, a point -3, 4, a point -5, 4, and an open circle at -7, 2. When we connect the dots. Okay, so again, what I'm saying here is not that this is still function g. I've added to it. It's a new function. But when I look at these two combined, I have the graph of an even function that looks just like g did in quadrant 1. So both pieces make up the new even function. Okay, lastly, I want to look at this graph that I have down below and figure out how I would get that from function g and use that to write up a formula that involves g for this graph. So this would be a great one to pause and try on your own. Always you can do that, but this is a really great one to give a try on your own. When I look at this, I see that it looks like I flipped upside down. So first is spotting the transformation that you think has happened. Then you need to figure out how to change the equation to reflect that. So if I want to flip upside down, I'm going to need a negative g of x. So first thing, I'm going to put a negative in front of the g. Okay. I see a couple of other things. One is this appears to be taller. It looks like there's some shift as well, because if I flip this thing upside down, it would end up down here. So this is just negative g of x. So in order to get this sitting on the x-axis, I think I would need to shift up. But I also see that this graph is only too tall. So if I shift up, the bottom won't be low enough. So I think I need vertical stretch as well. So vertical stretch, I need it to be twice as tall, 4 tall instead of 2 tall. So I'm going to do vertical stretch by 2. And then I need to shift the whole thing up. Okay, so this is where order becomes really important. If you're shifting last, when you stretch this thing, the top of it is going to end up at -4, and then the bottom is going to end up way down at -8. So you're actually going to have to shift it up 4 to get that to land in the right spot. And then you want to think about horizontal stuff. So is there any horizontal shift, stretch, flip, compression, any of that kind of stuff? I would say there's no horizontal stretch or compression, and the reason I would say that is because if you count this out, the original graph is 1, 2, 3, 4, 5 wide. I guess up here is the original, and it's still 1, 2, 3, 4, 5 wide. So it's not any wider or skinnier. But this thing, so far what I've done is flipped it upside down, stretched it out, made it taller, moved it up. I have it upside down and running from, let's see, -4. Okay, so this is where I'm at right now. Running from x equals 2 to x equals 7, I would rather have it go from x equals 0 to x equals 5. So it seems that I need to shift it to the left 2. Okay, so this isn't quite right. So I am seeing a -2 g of x plus 2 to get it to shift left 2. I don't really need another set of parentheses here. And then shifting up 4 also has to happen. Okay, so this, I think, will get me this final shape that I'm looking for. All right, thanks for watching.